Hey everyone. So I have been, or I've gotten a question, kind of asking to explain acids and conjugate bases a little bit. So that's what this little short video is going to be about. So remember what an acid is. Let's go with the Bronston-Lowry definition. So anything that is going to donate or get rid of a proton, a hydrogen atom, is going to be our acid. All right. So in this case, this HCl, hydrochloric acid, is going to be our acid. Once this reaction takes place and it loses its hydrogen ion, its proton, it's going to become a base. It's going to become a conjugate base. We say it's the conjugate base of hydrochloric acid because, again, these guys are connected. The hydrogen chloride, the hydrochloric acid here becomes a chloride ion. Okay. And we know this is a base because it has the ability to accept a hydrogen ion. Just kind of the reverse reaction here. And then the base, in this case, the base is going to be H2O. This has the ability to accept the proton to become H3O plus, a hydronium ion. So in this case, we have H2O being the base and the hydronium ion being its conjugate acid. Now, some people, some questions that I've been getting have to do with some polyprotic acids. In this case, so if we have let me pull up a blank thing real quick. So let's say we have the following. Let's say we have H2SO4. H2SO4 is going to dissociate and become a hydrogen ion and HSO4, right? And then this is going to turn into another. Let me rewrite this down here. Right, and then the HSO4 is going to lose another proton and become. These are 1 minus, SO4, 2 minus. All right. So, here's the thing. This is going to be the acid, right? It has the ability to lose a proton. Once it has lost the acid, this is going to be the conjugate base. So this is the acid, and this is the conjugate base. There we go. And then, if we had water in here, H2O, and we rewrite this as a hydronium ion, H3O plus, this guy would be the base, and this would be the conjugate acid. A point of confusion that I've been seeing is that some people are thinking that this H2SO4, sulfuric acid, this is going to be the acid, and this, the sulfate ion, is going to be our conjugate base. This is not true, right? Because it's not all the hydrogens that are leaving in one reaction. It is just one hydrogen that is leaving. They go off one at a time. So it's not, they all don't just all come off at the same time. They come off, the protons are going to come off one at a time. So if we're talking about sulfuric acid here, this is going to be the acid. Its conjugate base is going to be if a single proton comes off. So its conjugate base is going to be hydrogen sulfate there. All right. If we're talking about SO4, the sulfate ion, if this is the conjugate base, what is its acid? It's if we add a single proton to this, which would make this the acid. Okay, so anytime you're talking about acids and their conjugate bases, just remember that it's just a single proton that is gained or lost. Okay, we are only thinking about a single proton being transferred at a time. All right, hopefully that helped. I will see you guys later.